Ever wondered how that tiny pill of antibiotics you pop when you're unwell is made? Antibiotics, those small yet mighty warriors, have revolutionized modern medicine, offering us a fighting chance against harmful bacteria. But have you ever stopped to consider how these little lifesavers are created? It's not all lab coats and petri dishes, it's a complex, fascinating process that takes us from humble origins to high-tech laboratories. So are you ready to delve into the world of antibiotics? Stay tuned to uncover the fascinating journey of antibiotic production. Before we delve into the making, let's travel back to 1928, the birth year of antibiotics. Imagine a world where a simple cut could lead to a fatal infection. That was reality until a serendipitous discovery changed everything. Scottish bacteriologist Alexander Fleming, working in his lab, noticed something peculiar. Some mold had contaminated his petri dishes filled with Staphylococcus bacteria, but instead of ruining his experiment, it created a bacteria-free circle around itself. This wasn't just any mold, it was a rare strain of Penicillium notatum, and it was producing a substance that killed bacteria. Fleming named this substance penicillin, marking the dawn of antibiotic medicine. This miracle mold was a game-changer, saving countless lives by combating bacterial infections. It was a marvel of nature, a tiny organism that could vanquish disease-causing bacteria. Now, let's fast forward to the 21st century and see how antibiotics are made today. The first step in the making of antibiotics is fermentation. Now let's dive into what that actually entails. Picture this. You have a controlled environment, like a large sterile vat. Here we introduce our star performers, specific types of bacteria or fungi. These tiny life forms are like nature's little factories, churning out the antibiotic substances we need. But it's not just a case of throwing them in and waiting. Oh no, these microorganisms are quite the divas. They require a very specific diet of sugars and nitrogen sources, among other things, to flourish and produce optimally. The conditions within the vat are also meticulously maintained: temperature, pH, oxygen levels, all to ensure our bacterial or fungal stars are in their prime. Over several days, these microorganisms multiply and ferment, producing the antibiotic substance as a byproduct of their growth. It's a slow, intricate dance of nature and science. Once fermentation is complete, it's time for the second step. Next, we isolate and purify the antibiotic. Now the curious might wonder, what does this isolation and purification entail? Well, it's all a matter of chemistry. After fermentation, the antibiotic is combined with other materials. So we need to separate it out. Picture a party where you're trying to find your friend amongst a crowd. That's essentially what we're doing here, except the crowd is a mixture of substances, and your friend is the antibiotic. We use a process called extraction, where we apply a solvent that only the antibiotic will dissolve in. This allows us to separate the antibiotic from the rest of the mix. Next, we purify it. Now imagine that your friend is covered in glitter from the party. To get rid of the glitter, or in our case any remaining impurities, we use methods like crystallization or distillation. These processes ensure we have a pure, usable antibiotic. Now that we have our antibiotic, the final step awaits. The final step is refinement and packaging. It's here that the antibiotic undergoes a series of rigorous processes to achieve its purest form. This refined product is then carefully integrated into different mediums, such as tablets, capsules, or liquid solutions for injections. These forms are chosen based on their effectiveness and ease of use. The process concludes with secure packaging to maintain the antibiotic's potency and safety. And there you have it, the fascinating process of making antibiotics. So, that's the journey of antibiotics, from a humble fungus to a life-saving pill. A fascinating process, isn't it? We've traveled through time, back to the origins of antibiotics, and traced their development from discovery to deployment. We started with fermentation, the crucial first step, where our friendly fungus, Penicillium, produces the antibiotic substance. But it's not just about brewing a microbial soup. The substance then needs to be isolated and purified, a delicate task requiring precision and expertise. And the journey doesn't end there. The purified antibiotic undergoes further refinement, followed by meticulous packaging, ensuring that the final product is safe, potent, and ready for use. The production of antibiotics is a complex, intricate process, underlying their immense value. These tiny pills save millions of lives every year, a testament to our scientific prowess and relentless pursuit of better health. Next time you take an antibiotic, remember the intricate journey it has undergone to reach you.